So in this video, we're going to go over the Society of Actuaries ExamP sample question number 20. An insurance company issues life insurance policies in 3 separate categories: standard, preferred, ultra preferred. Of the company's policyholders, 50% are standard, 40% are preferred, 10% are ultra preferred. Each standard policyholder has a 0.010 probability of dying in the next year. Each preferred policyholder has a probability of 0.005 of dying, and each ultra preferred policyholder has a probability of 0.001 of dying in the next year. So a policyholder dies in the next year. We want to calculate the probability that the deceased policyholder was ultra preferred. All right. Now, what I'm going to do, so this is clearly to me a Bayes theorem problem, right? I'm going to make a chart for this just to make managing the formula for it a bit easier to work with. So I'm going to denote the following. I'm going to say the probability of being, standard is S, preferred is P, ultra preferred is U, right? So I'll make a chart like this, and it's important. Normally, if you've seen some of my other videos, I kind of make a grid, almost like a chart. And here I'm making kind of something else, right? More of like a table. The difference between those two, and I might have just an example close by. I do not. Right here. Yeah. So the difference between something like this and something like I'm making here is this is useful when the information they give me is intersections. Whereas what I'm doing here is what they're giving me is conditional probabilities, right? So let's say the probability of the type of policy you have, which I'll call PO, right? So this column will be the policy you have. This column will be the probability of having that specific type of policy, while this column will be the probability of dying given that you have that kind of policy. So you're either standard, preferred, or ultra preferred. Now, 50% of the policyholders are standard, so that's 0.5 here. 40% are preferred, 0.4 here. And 10% are ultra preferred, so that's 0.1. Each standard policyholder, so given you're a standard policyholder, the probability of dying is 0.01. So that's 0.01. Okay, not a theta. The probability that you die given that you're a preferred policyholder is 0.005, right? And notice it doesn't say given, but you can kind of tell by the wording. That's something that's important to get used to, is understand when you have an intersection, right? And understand when you have a conditional probability based off the words they're saying. In the beginning, some people can get confused, right? But honestly, it isn't that difficult if you read through just a couple of questions and some examples. And then ultra preferred has a probability of 0.001 of dying in the next year. So that's 0.001. Okay. Now, what we're looking for is the probability that the deceased policyholder was ultra preferred. So the probability that they were ultra preferred given we have somebody that died. So standard conditional probability formula is the probability of being ultra preferred and dying over the probability of dying. Now, if you notice, standard algebra in an equation where we have 3 unknown things, in order to get this one, we need to know the other 2. We don't have any of these pieces of information, right? So we can use these to get it, and that's where Bayes theorem comes in. So again, I don't currently have a video on Bayes theorem. If anybody wants one, leave that down in the comments. If I eventually make one, I'll link it in the description. But I don't have time to go through it in this video. So it'd just be too long. So the numerator would then change to the probability of dying given that you were ultra preferred multiplied by the probability of being ultra preferred, while my denominator is the probability of dying given that I'm ultra preferred times the probability I'm ultra preferred plus the probability of dying given that I'm preferred times the probability of dying times the probability that I'm preferred plus the probability of dying given that I'm a standard policyholder times the probability of being a standard policyholder. Filling in that information, my numerator becomes 0.001 times 0.1. The denominator becomes the probability of being, let's see, it's going to be 0.001 times 0.1 plus 0.005 times 0.4 plus 0.01 times 0.5. And that I'm just going to put into a calculator. All right, and let's see. So just give me one moment. Numerator is 0.001 times 0.01, times 0.1. Denominator is 0.001 times 0.1 plus 0.005 times 0.4 plus 0.01 times 0.5. And the probability I get there is approximately 0.01408, and that just continues. This thing wants to be rounded. The answer choices are rounded to 4 decimal places, so I'll round this to 4 decimal places, right? And that's going to be 0.014, and then 8 rounds up to 1. So this is my final answer, which lines up with answer choice D. Okay, so this was mainly a Bayes theorem problem. When you're given a problem like this and they give you, so the probability of dying, right, is something applicable to all categories. And the probability of being that category, it's probably going to be a Bayes theorem problem. The kind of telltale sign for a Bayes theorem problem is when they ask you this, the probability of A given B, right? However, the information they give you is this, the probability of B given A, right? That tells you that, hey, this might be a Bayes theorem problem. So other than knowing that formula, the other useful thing here, although not completely necessary, just kind of makes your life a lot easier, is understanding how to throw this into a chart and categorizing each thing. That way I don't really have to think about how I'm splitting this up. I just write down the formula, grab the numbers from up here. However, that's more of a, I wouldn't say formatting, but just kind of a strategy thing, right? Making your thought process a bit more streamlined, right? Efficiency, that's the word I was looking for. If there are any questions, leave it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button and subscribe. That totally helps me out. And other than that, good luck, guys.